This video we're going to introduce the concept of redox. Now you should have covered redox at GCSE. Redox is reactions that include reduction and oxidation, that's where the name comes from. And reduction and oxidation are a process of electron transfer. So electrons are going from one chemical to another, and that is going to be a redox reaction because the chemical that loses the electrons is going to be oxidized and the chemical that gains them is going to be reduced. Oxidation is loss, reduction is gain. So you can fill in those key definitions now. So it's really important that if you have remembered that mnemonic, oxidation is loss, reduction is gain, that at A level you realise you must say of electrons at the end of that. You can't just say oxidation is loss. It's not losing its money or its shoes, it's losing electrons. So you need to make sure you're very clear with your definitions. They always have to occur together because if something loses electrons, they don't just fly off and float away, they've got to go somewhere. So it involves the transfer from one species to another, and the transfer of electrons must be a set number, so the electrons lost must equal the number gained. So these are just some key principles. Let's have a look at putting that into practice. I want you to think back to the start of your chemistry studies and think about what happens when a metal reacts with an acid. So when a metal reacts with an acid, we're going to form a salt. So magnesium plus hydrochloric acid, the salts of hydrochloric acid are chloride, so we're going to get magnesium chloride, and we're going to get hydrogen gas, not water, hydrogen gas. So stop the video now, pause it, and see if you can write a balanced equation for the reaction between magnesium and hydrochloric acid. So your balanced equation should look something like that. And we're now being asked, in order to help us see just the important things, the things that are undergoing this redox reaction, we want to turn this into an ionic equation. Now, if you remember from the introduction to chemistry, it's helpful to have state symbols. So do you think you could add state symbols to that top equation? So if you've added state symbols, you should have got that. Now, we're going to think back to how we construct an ionic equation. Remember that anything that is solid, liquid or gas is going to stay as it is, and if it's aqueous, we're going to split it into its ions as long as it's aqueous and ionic. So things are ionic if they contain a metal and a non-metal, or if they are an acid, acids are ionic, and we're going to split the ionic things into separate ions. And anything that's solid, liquid or gas or covalent is not going to be split. See if you can split these up into their ions, and then we will have a look at what that leaves us as an ionic equation. So there you go, we split the acid and the salt, because they were the two ionic species, into their ions. Now we're going to cancel out anything that is appearing on both sides. So we've got these two chloride ions, and they wouldn't appear in our overall ionic equation. So if we remove those, we'll see that the overall ionic equation is magnesium plus 2 protons makes Mg2 plus and hydrogen. And if we think about that, we can have a think about what's going on. How does Mg become Mg2 plus? Well, it must lose 2 electrons. So it's losing 2 electrons. And how does 2 H pluses become a H2? Well, that must be gaining 2 electrons. And we've got 2 H pluses which have no electrons forming a H2, and if you think about your GCSE diagram of hydrogen, there are 2 electrons there in the shared pair in the covalent bond, and so magnesium is losing 2 to become an Mg2 plus ion, and the 2 hydrogen ions are gaining 1 each, 2 in total, to become a hydrogen molecule. So which one is being oxidized, which one is losing electrons, and which one is gaining electrons? So we can see that in red, our magnesium is being oxidized to Mg2+. Now in chemistry, unlike in maths, in chemical equations we don't use a minus sign, so rather than taking away 2 electrons on the left, we're going to add 2 electrons to the right that they have been lost from magnesium, and this would be what would be called the half equation for the oxidation of magnesium, and then the half equation for the reduction of hydrogen would be hydrogen ions gaining 2 electrons to become hydrogen molecules. We'd have that. So these are called half equations, and they balance not just for atoms but for charge as well. So if we look at the left hand side of the top one, we'll just have a look at our left hand side versus our right hand side. In terms of atoms, there's 1 mg on each side, so they balance for atoms. And then in terms of charge, the left hand side has no charge and the right hand side has a +2 and 2 lots of -1, so 2 minuses. So that adds up in total to be 0. So we balance for atoms and we balance for charge. So a little question for you now. I want you to have a look at these and decide whether the species in bold, so the thing in bold, which is here, here and here, yeah, so this is the one in bold, has it been oxidised, so remember oxidation is loss, or has it been reduced, reduction is gain. So just pause the video and have a go at that question. So there we go, bromine has been reduced, it's gained electrons. Magnesium has been oxidised, it's lost 2 electrons. And oxide ions, O2-, has been oxidised. Be careful, it's not oxygen. Oxygen's on the right. Oxide ions have been oxidised. So our second little problem for you to have a go at is, can you use your knowledge of dividing into ionic equations to decide what has happened to each species? So divide it up into an ionic equation, just like we did for the magnesium example on the last page, and then decide which is being oxidised and which is being reduced, and write half equations. But our first step is to split up those things that are ionic, and then we're going to cross out our spectator ions, and we're going to remove those. And if we get rid of those, we've got the ionic equation. Now what we need to do is split it up into things that are happening to each species. So we've got Fe going to Fe2+. Now how does it do that? How does Fe become Fe2+? It loses 2 electrons. And then we've got Cu2+, picking up those 2 electrons to become Cu. So pause the video and decide which one of those was oxidation and which one was reduction. And if you've done that, you should have got that as the answer. Have a go at the next question yourself. So step 1 is to split the things that are ionic. Now, despite being aqueous, the chlorine is not ionic because Cl2 is not made of a metal and a non-metal, nor is it an acid. It's a covalent compound, and therefore we're going to leave it as it is. If we get rid of the spectator ions, in this case it's the potassiums, so if we lose those, what we're left with is an ionic equation that looks like this. So can you split that into 2 half equations? And can you decide which one is oxidation, where there's a loss, and which one is reduction, where there's a gain?